Okay, so question 8. Which statement describes conservation of energy in a closed system? So let's have a look what they start with. When there are energy transfers, when there are energy transfers, when there are no energy transfers. Let's start with C and D. When there are no energy transfers, the energy reduces. Garbage. When there are no energy transfers, the total energy increases. Equally garbage. So we go back to the top two. When there are energy transfers, the total energy reduces. When there are energy transfers, the total energy does not change. So what we're saying is we can move from one store of energy to another, but the total energy stays the same. So it's got to be B. Okay, the next one. A student uses the apparatus to find out which two materials, sand or sawdust, is the better insulator. And hopefully you remember the practical where I gave you some kettles and you had to insulate a beaker. Well, we're swapping the beaker for a can. Now, the large can is so that we can pack sand or sawdust, and the small can is so that we can put some hot water in. That's the basics for that 3 marker. Now we're going to need a thermometer. That's going to have to go in. We're going to have to need a measuring cylinder so we can measure the volume of water to keep it the same. And it then says draw a label diagram to show how the student should set up the equipment. It just needs to look like that. So the big can, little can inside, whatever the insulation is. So you can see here in the answer. So this would either be sand or it would be the sawdust. We've got our thermometer inside the water and our hot water's there. So that one's quite nice. Give 3 factors the student must control in this investigation. Same volume of water, same mass of insulator packed around each of the cans, same starting temperature of water are the really obvious ones. So those 3, but same temperature interval to measure. So you're going to measure every minute until they reach room temperature. Okay, expanded polystyrene is used to insulate buildings and it's got different densities. And we can see density going up here. And we've got thermal conductivity. So the denser you are, the less of a conductor you are. Perfect, that makes loads of sense. Describe how thermal conductivity changes with the density. That's our usual thing in analysing a graph. So as density increases, thermal conductivity decreases. Mark, and the next part is, that is a non-linear relationship, or it's decreasing at a decreasing rate. So it's a non-linear relationship that levels off. Next one, we've got a Sankey diagram. So just going to have a quick check. 3,000 in, 2,400 to heat the water. So just highlight that. The rest is lost to the surroundings. That's dissipated into the air. Clearly that must be 600 joules. So it says calculate the amount of energy lost to the surroundings. Well, we've done that already. 3,000 take away 2,400 is 600. And then it says calculate the efficiency. So it's the energy transferred by the kettle divided by the useful over total. So it's our efficient, useful tools. And we can go in to say that was our useful energy. That was the total energy we put in. So there we go. And the efficiency is 0.8, or if it wanted it as a percentage, times it by 100, 80%. That's that question done.